Hello everyone, today we're going to solve this linear system by Gauss-Jordan. Here we have our augmented matrix, and first we'll do in row 2 minus 2 row 1 plus row 2. So we eliminate all this row, and also we'll do minus 2 row 1 plus row 4 in row 4. Giving us the result minus 1, minus 2, 0, minus 3, minus 1, and here 4, 18, 0, 18, and 8. Okay, so next step we'll do minus row 2, so we'll get this. Then in row 3 and row 4, we're gonna do minus 5 row 2 plus row 3 and minus 4 row 2 plus row 4. So we'll get here 0, 0, 0, 0, 0, 0. And here we'll get 0, 0, 0, 6, 2. Okay, now we're going to change this row in row 3. So we get this whole line of zeros. And the next step is to do row 4 times 1 over 6. No, sorry. Row 3. So we'll get rid of this. Okay, so here we have a row echelon form, but we're still missing some parts. We'll do row 2 minus 3 row 3 plus row 2. We have 1, 2, and 0, 0. Next we'll do row 1, 2 times row 2 plus row 1. Here we have a 0 and here a 4. Okay, so then we can convert this into a system of equations, giving us x1 plus 3x2 plus 4x4 plus 2x5, 0, x3 plus 2x4 equals 0, and x6 equals 1 over 3. Then solving this little linear system, we find x1 equals to minus 3, and we give an r to this x2. We give an s, and we give a t. X2 equals r, x3 equals minus 2s, x4 equals s, x5 equals t, and x6 equals 1 over 3. And this is our final solution. Si quieres mandarme ese aquí.
¿Lo corto?
Okay, so then we have this exercise: find all values of C, if any, for which given matrix is A is invertible. So we'll do row 1, we'll move it to row 3. So we have 1, 1, C, 1, C, 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 C. And then in row 2, we're gonna do minus row 1 plus row 2. In row 3, minus 0, 1 plus row 3. So it will be like this: 0, 0, 0, C minus C to the power of 2. And then theorem 1.53 in the book says if A is a n times n matrix, A is invertible, and B, the reduced row echelon form of A is identity matrix. Sorry, so we have in row 2, in this, if C equals to 1, we will have here a 0, so matrix is not invertible. And in row 3, here, if C 1 C equals 0, then C can be 0. So the matrix is not invertible for C equals 1 and C equals 0. We need to find the same values of C for this matrix is invertible. We'll do change row 1 and row 2. We'll do 1 C1, C1 0. We're also gonna change row 2 and row 3. 0 1 0 C and C1 0. After doing this, we're gonna do minus C times row 1 plus row 3. So we find here a 0. Here 1 minus C to the power of 2 and minus C. Then we'll do C to the power of 2 minus 1 times row 2 plus row 3. And we'll eliminate this, doing a 0. And here C to the power of 3 minus 2C. And finding this, if C to the power of 3 minus 2C is the same as C times C to the power of 2 minus 2 equals 0, that is, if C equals 0, matrix is not invertible. And also, solving this equation, we find that C equals to square root of 2 plus a negative. This matrix can be invertible.